Okay. So pedagogical content knowledge. Get that back. That one. Okay, has anybody ever heard of the word pedagogical before? Or pedagogy? No? Okay. This word is anything that relates to teaching. Okay. Your pedagogy is the way you teach. Okay. Content is your subject. Just strictly the subject knowledge. If you're doing it separate, like your content knowledge is what you know about your subject. Could be whatever, because you guys will be elementary teachers, so you have to have content knowledge in math, science, language arts, reading, social studies, all those subjects. You need to know content. Okay? And knowledge, of course, is knowledge. But pedagogical content knowledge, when it's put together, is the knowledge you have to know in order to teach your subject. Okay? It's different than just knowing your subject. What you've done through elementary school up till now is solidifying your content knowledge. But it takes a different type of knowledge to be able to teach it. Okay? That's what we're going to go for in this part of the last half of 1.7. Okay. What we need to do is we need to analyze student work, and that's the best way to bolster your content, pedagogical content knowledge. Okay. Sometimes people call that PCK for short. Okay. All right, so what we're going to do is we're going to take a look at some student work. This is John, and he added these two numbers in this way. Now, everybody knows how the algorithm works for addition. Okay? You add the ones first, you put down the ones, and then you group the tens together, put it in the tens column, okay? And then you add the tens. Algorithms are the step-by-step process to add numbers that you've known your whole lives. Okay? We've done some work today at the concrete, or not this, in this unit, at the concrete and pictorial level. That's stuff you probably didn't know before, but math is the same structure, makes sense. The abstract ways, you probably know better because that's what you've been taught in school. Okay, some of you might have seen some of the picture ways or the concrete ways before. But here, John is trying to do this abstractly, which is a little bit faster than getting out blocks and grouping blocks together. And he wrote this as the answer. This is his work. You're coming around to his table and he has this as his answer. And you got to say, okay, John, what you got to assess what he did and give a recommendation of how he can improve or get more accurate in his process. Okay, any thoughts about how he added this? First of all, you check to see if it's the right answer and then go back to how he got it. Okay. Go ahead, Camille.
So I think that what he did is he added the 13 backwards, so he carried the 3 and put the 1 down.
Mm-hmm.
And so it would be the opposite. And then he just wrote the 14. So he'd need to put the 3 and the 1 up. The 3, like switch the 3 and the 1 that he carried. Does that make sense?
Right. So you can see how he needs to correct his work. And the word carry is what we use traditionally. Now, you got to be careful about this in this class. We're going to try and have you think more about what you're saying. If you carry a 3, is that what you're really doing? Picking something up and moving it around?
No. No, we're adding it to the rest of the equation.
Yeah. So it's sort of carrying, but we want to try to find better words to describe this so that the students don't get confused between the English and the math.
Like moving it to the tens place?
Yeah, moving. What happens if with you're in base 10 blocks? What happens? What are you doing with like base 10 blocks?
You're regrouping.
Grouping,
Right.
rebundle.
Well, okay. So here's, and even regrouping is something that people teach traditionally, and even my colleagues do. But let's take a look at what happens here. I'm going to draw dots that represent the cube, little cubes. Little cubes are worth 1. There's 5 here, and 5 from the 75, and then 8 from the 48. What are you doing when you are going to find the total between them? You group them all together, right? Because you're adding. And because we're working in base 10, we have to take 10 of these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to take these ones right here. Now let's think of the word regrouping. Am I regrouping something, or am I just grouping something?
If you're just grouping it, you're just making it into a 10. If you're regrouping it, you're moving them from the 1s over into the 10s.
Yeah, I would say grouping the 10s together. Another word that people use in this context is called bundling. How do you spell that, I think? Is that how you spell that word? Grouping or bundling. Because like there's some manipulatives like the base 10 blocks, but other people use sticks, straws, they use toothpicks, okay? So you can bundle them together like a hay bale or something, or just bundling a pack of sticks together. Okay, so those are 2 words that you can use. With base 10 blocks, you're more grouping them together. Okay? When you're grouping them together and then you're moving them or putting them or exchanging them for 10s, okay? Because you'll put these into a box and you will grab a rod, okay? So you're grouping it together and you put the rods with all the other rods. So you're putting them all in the same place. I really don't mind which words you use, just as long as you're being accurate in the English of what they're doing with their actions, okay? So with the numbers, it gets more abstract because we have digits here, symbols that represent the quantities and not the quantities themselves. So it's hard to see what words to use. So we want to use grouping or bundling. I'm going to take my 13 and I need to group the 10 ones and put that with the 10s column, okay? But John didn't do that. No, he switched it, right? And so he grouped he put the 3 with the 10s, but the 3 are not 10s, they're 1s. Okay. So you guys have that one down. He switched. The 10s and 1s. So I would say the amount of 10s and 1s. In the recording, in how he recorded, the sum of the 1s column. Okay. So a part of the homework will be to talk about what he did or what these students did, and then we're going to have recommendations about what you're going to do as a teacher. Okay. What do you guys think you should do when you see a student do that? Any just initial thoughts?
Ask them their thought process and see how, like why they put that 3 up there instead of the 1.
Great. So that's what my first go-to is. Okay, and I just got my 10-minute warning. I'm gonna end, and I do plan on getting the Zoom license or trying to find a solution. So I fill out a form for it. So I traditionally just ask them how they got their answer. Most of the time, if they explain to you what they did, they will be able to see where their mistake was. And you want them to discover their mistake. So that's a good teaching philosophy. They will learn more from their discovery of their mistake than they will if you told them what their mistake was. Okay. So use their thinking as much as possible. If you start to impose your thinking on them, then it takes them a minute or longer, or not even at all, to understand your thinking. Sometimes they don't even get it. So you got to try to use their thinking when they discover their mistakes. So a way to do the recommendation is first ask him how he got his answer. But if you want a more specific question, ask him how he got his answer. Sometimes they might not have much to go with that one, and they just say, I don't know. So you can ask him again, further question, you can ask him where the 3 came from. That was the one that was misrecorded up here. Where did this 3 come from? Okay. And hopefully he can see that it's 3 1s and not 3 10s. Now, he's working abstractly right now, so he just has like his whiteboard or whatever worksheet he's working on. Maybe he will get it. I'll say, oh, the 3 came from the 1s, and I should record that in the 1s column and not the 10s column. Maybe he won't. If he doesn't get it, you can ask him to model. You go down a level of abstraction. You have these, working with these digits, it's pretty abstract. Go down a level to picture, or even down to concrete level, to have him see where mistakes go. Because you go with the model, you can have him model the solution, and he can see that with the base 10 blocks that the 3 1s are not like the rods in the 10s place. Okay, so you can't combine those, you can't write those in the same column because they're just not like each other. So you can see that with the lower level of abstraction. Oops. So you ask him where the 3 came from, and if it's like the other numbers in the column. And if he doesn't get that, you can also go ask him to model. Model with base 10 blocks. Okay, or some other model. Okay. All right, let's go on to the next one. This is Sally. And Sally added hers this way. 75 plus 48 is 113. Okay, so take a look and see what Sally did. What did Sally do that wasn't correct? Or is it correct? Maybe she did it all right.
She forgot to carry over the 1 from, or the 10 from the 13.
Okay, tell me more what you mean by that.
So she added the 3 right in the 1s, but when it was time to carry the 10 over for the 13, she didn't write it above, so she forgot to add it. So she got 70 plus 40, which is 110, instead of 1 plus 7, or 10 plus 70 plus 40, which is 112.
Yeah, she needs that 1 up there, right? So put it in green. So she did not record. So great thoughts. She didn't record the group of 10 1s. Now the group of 10 1s that came from the 5 and 8. Oops. Okay. So it got lost, and it's not configured in the answer, or figured in the answer, so that means her answer is off. Okay. So she didn't record the group. Sorry about that. She didn't record the group of 10 1s that came from the 5 and 8 in the 1s column. Look at that in parentheses. Okay. She didn't record that 10, group of 10 with the 7 10s. and 4 tens in the tens column. All right, recommendation. Now that you discover that she's doing this, how would you guys recommend procedure? What should we do next?
Start with the same that you did with John. Ask them their thought process.
Yeah, you can always ask their thought process, yes.
And then
Or even
ask,
simpler, you can just ask them to look at the problem and see if they forgot anything.
Good.
Ask them if they can like recognize their own mistake and just say like, hey, did you forget something?
Mm-hmm.
Well, and sometimes they do it just backwards. So they do the 7 plus the 4 first, and then they do 5 and the 8 second. And then they don't know what to do with the 13. That 10 that is grouped.
Yeah, and those kinds of things are great things to think about. With some students are smart enough that they can handle adding the tens together first. And it's even one of the mental math strategies that I hope we get to with the next chapter. I don't know. This is a different kind of course that I've taught before. And so you can add those together, but then you have to like compensate for any extra tens you get from the ones column in your head. But you can ask her how she got her answer, so you can see which process she was using, and you can ask her where that 3 comes from again. Okay, that represents the ones, and if it comes from like the 13, she will maybe discover that she didn't record the 13 or consider that in her answer. Okay. And so we need to model the problem if she doesn't understand from your questions about the abstract versions. So you can model a problem with base 10 blocks. Okay, class. Let's see. Okay, so we've ended with Sally's recommendation. If she's not seeing where these hints are getting to her, or coming from, about where her mistake was, modeling the problem with base 10 blocks is a good idea. You can see with base 10 blocks where the grouping or bundling are more evident in how the numbers have to follow what the model is showing. A lot of times we take the numbers and we just put them wherever we want. They just can't go exactly wherever they want because it doesn't follow with the real life application or the models that you have. So discovering the structure is one of the practices of mathematics. One more for pedagogical content knowledge, we have Joe. And Joe has written this down. Any thoughts about where he made a mistake?
So this is another where he might have done the tens first and then the ones, and then he had 13 ones.
Okay, good. So he could have added any other thoughts? And I didn't even bundle the 10s at all. Okay, so yeah, the same story as if he added the 1s first and then the 10s, but he's not recording or grouping the 10s together. Okay, so here we have 1 10 from the 13, we have 1 10 from the 7 and 4 and the 11, 7 10s and 4 10s. Okay. These two need to be grouped together, but he wasn't grouping them together. He didn't know how to handle that. So the recommendation, we can ask him to model. Any other recommendations besides mine's like modeling or asking him where to go? Any recommendation? That's how he got his answer.
I would help
Let's see how he
him.
does the 10s and 1s. Go ahead.
So I would help him understand that that 1 that he put by the in front of the 3, instead of putting it up, it needs to be added in still. So it would go above the 7 because it's not added into the final total. And so it needs to be added into the 10s group instead of just written into the 10s group in the bottom.
Yeah, he needs to
I don't know if that makes sense.
combine 10 from 13. Okay. You can also model. Base 10 blocks.
Another thing is like if he did it backwards in steps, it would just be another re-explaining of what order the steps are done in.
Mm-hmm. So it's important for, ideally, if you can get the students to understand both ways, that'd be great. But they should know what traditional algorithms are and how they work, because algorithms do have an advantage because they're very efficient, but you can lose a lot of meaning in them. Right? But they are good to know, because that's how people learned it, like their parents and stuff, and they're also pretty fast. But there's other ways of doing math besides the algorithm. Okay, so that's all I'm going to say for that section.
Did we go over homework questions already, or when would be a good time to ask?
We already had a chance to do that, and we got 20 minutes, so hang on after class if you can.
Okay.
And okay, so that's that one. I'm going to stop this here for a second.